Well, see, I gotta be like I have to be in in a seat in class.
Yeah.
Usually right up front, up close.
And my teacher sounds like a banshee whenever she speaks. I
What math
won't
is it?
say her name, just savor the embarrassment, but oh my god.
What math are you in?
Math 90, just to start, but I'm gonna just jump to college algebra after this. I can't stand the monotony.
So here's your light bulb. We just did that problem, right?
Yeah.
All right. Yeah, I mean that's basically the problem we just did there, and
CFO is trap.
yeah, and what the other thing this is trying to show is that the see these little bumps, those little black bumps. That's showing the relatively low cost of the compact fluorescent. That's how frequently you're buying a new one.
Okay.
That's how frequently you're buying a new one. And even though
The
this,
blue one's the best, halogen. Because it only has one. Well, no, the incandescent doesn't have any.
well, it depends. Like if you're just gonna use the thing for a few hours, this is your best bet.
I see it. Yeah.
You know, if you're gonna use it for this long, the blue one is your best bet. But if you want to keep the lights on longer, the CFL is. So they each sort of win at a different time scale.
It's like what you're looking for, kind of.
Yeah. So like the black's out in front. Ooh, the blue just took over. Oh, now the red's going to win in the long run. Make sense? Okay.
There's always a trade-off. CFLs have proven to cause headaches.
Yeah. Okay.
Nasties.
Now let's look at this time value of money problem, and the classic scenario, and this has been played out in numerous places, is the question is, would you rather have $1 right now, or would you rather have $1 tomorrow? So most people would say, I'll take it now, please. I'd much rather have it now. But then the question is, well, how about this? Would you rather have $1 now or $1.50 tomorrow? Like, well, $1.50 is more than. So, and then you at some point you reach this break even. Would you rather have $1 now or like $1.01 tomorrow? And at some point it's like just give me the dollar. So so money, and we saw this with inflation. We did the whole inflation thing last time. So money, like a single dollar, becomes less and less valuable over time because there are more and more dollars around, right?
More of a printed or whatever.
Yeah, and so and we also discussed the fact that when money is loaned, more money needs to come back in the future so the banks themselves can stay in business and stay ahead of the base inflation rate. Okay, so the functions I'm going to show you, and these are in your textbook. If you take a look at page 484, there's this thing called the present value. And there are 6 basic discounting formulas.
What page did you say?
I'm on page 484.
Okay, thank you.
Sure. And I'm also going to show you, there's a neat little table. I don't know if you guys ever remember, like back in high school, if you had like the trig tables in the back of the book, but these are showing you that exact problem they show you. What's money worth in the future? What's it worth now? What's it worth in the future? And I'm going to take you right into a little spreadsheet that we use for another course here in the Energy Tech program. ETEC 214. So this is energy storage and distribution. And if you want to take a deeper dive into this stuff, I recommend grabbing this course. One quick sec to find it. Okay, so I'll make this a little bit bigger so you can see it. Okay, so the here's what we're looking at. I'll draw it out graphically. And the figure looks a lot like this. So, again, let's just look at it. Let's just look at it kind of simply. Let's say I've got $10, and I'll give you 3 scenarios. Actually, I'm going to draw it like this. I've got $10, and I'll give you 3 separate scenarios. And we'll just call this P, we'll call this A, and we'll call this F. And let's see, let's make each one of these be $2. There's 2, 4, 6, 8, 10. So in one scenario, there's 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. And this is 2 years, 4 years, 6 years, 8 years, 10 years. So there's 10, here's 10, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Okay, so in one scenario, it's a little bit bigger. Ooh, pink money, okay. So in one scenario, I can just give you $10 right now, right? In another one, I could give you $1 each year for 10 years. 2, 3, 4, 5, 6, 7, 8, 9, 10. It's still the same $10. Or in another scenario, I could give you all $10 in 10 years. So most people are going to select this because you're thinking because I can actually go and do something with the money. Maybe I'll invest it, maybe I'll go buy something so I can get to work, et cetera. So you've got those 3 scenarios to deal with. So you've got the present value, the annuity getting paid out over time, or the future value. So we know in general this $10 given now, unless you actually invest it at a competitive rate, it's not going to be worth $10 in the future unless you invest it. So let's see how different these 3 things are. So what I've done in this little spreadsheet is come up with these equivalence factors. So I just used the example of 10 years, so I'll stick with that. And you can see that in these 3 different ways that we can think about money, there are different ways to convert them among each other. So let's just do that here. So I can convert the present into an annuity. I can convert the present into the future value. I could also convert the annuity into the present value, or I could convert the annuity into the future value, or vice versa. I could take know in the future what's the annuity. If I know the future, what's the present value. Now, all of this depends on how quickly the value changes. That's really it. That's really all it depends on. So, when we look at, okay, what's the Fed rate right now, whatever it is, like 1%, or it's small, and the whole point is really to make money more available, less valuable, so it flows more easily. When that rate goes up, you're kind of throwing sand into the gears, so the whole thing slows down a little bit. So let's just look at those specific formulas. So here's the present value as a function of the future. let's just see where this guy is in the book. So in this case, I've got the formula written out in Excel, and now I'm going to write it. And let's just make the interest rate be, well, first let's make it be 0, and I'll show you how these formulas work out across the board. So if I'm going to make this point, I can't make it exactly 0 because it'll go to infinity, but let me make it very close to 0. Okay. So if we look at this, let's just say I had $1,000 now. Actually, let's just go with 10 because we were using 10 before. So I've got $10 now. If the money does not change in value much, it's still going to be worth $10 in the future. Same thing. So the present value and the future value of the money are almost equivalent if the discount or the interest rate is nearly equivalent. If I take this now and say, let's just go to 0.1. So we're just focusing right here. This is now the F to P and the P to F say that if I've got $10 and it's gaining interest at 10%, in 10 years I'm going to have $25.94. So let's just look at that one. That's kind of the easiest one to think about. So again, I've got $10 now. $10 now. It's going to make 10% per year. It's going to be worth $25.94 10 years from now. So let's just examine that one. That's kind of the easiest one to look at. So where does that come from? So actually, let's go here. I've got 2, 4, 6, 8, 10. And we know the answer in 2, 4, 6, 8, 10 is going to be up here at, so this is 10 years, $25.94. $25.94. So how did we get from here to here? So this is, again, money on this axis, time on this axis. How did we get there? So it's B6. So what's in B6? Well, B6 is the amount I have right now. So the future value equals the present value times 1 plus, so multiplied by 1 plus B4, well, what's in B4? 10%. I'm just going to call that the interest rate. To the 10th power. I'm going to just call that n. So that's the formula. So F is the future value, P is the present value, I is the interest rate, and n are the number of years. So here we go. So 10 times 1 plus 0.1 to the 10th power. And let's just run that on the calculator offline here. So I think I can do that here. So if I have 1.1 y to the x 10 equals 2.59, etc., times 10, 2594. So I just ran it with the with the calculator. Okay, so it works out. So this one is kind of the easiest one to understand. So we know we've got $10 now. We're going to make 10% per year. There's $25.94. This one says if I have if I want $10 in the future, I'm gonna have to put $3.86 in right now. And so if we ran it, this guy's the same way. You can see it looks almost the same. It's just you've got a negative there in the exponent. And I won't dig through all the math, but those are the two deals. This one gives me the present value if I want an annuity of $10. So this is a little more complicated, but it's saying that I can either have $61.45 now, or I can have $10 a year for 10 years. Does that make sense?
Yep.
So that's the question. So that gets back to that very first question. Would you rather have $61.45 now, or would you rather have $10 a year for 10 years? Well, if it's a 10% rate, either one. There's no difference. I'll take either one, right? This one says I can either have $10 now or $1.63 per year. And the point is, they're equivalent. The point is they're equivalent. You have $10 now or $1.63 per year. This one is, I can either have, what is this, guys? This is the future and the annuity. Well, let's do this one first. I can either have 63 cents per year or $10 in the future, right? Because you can say, well, I'd much rather have, and again, they're exactly the same if money's worth 10, goes up by 10% per year. Then what's this one? Future and the annuity. I can either have 63 cents. Oh, yeah. I can either have, oh, this is kind of the weird one. I can either have $10 per year for 10 years, or I can take $160 in the future. Because obviously $160 in the future is a lot more than 10 per year, but not if I've taken that $10 every year and done something, invested with it.
Okay.
Right?
That was weird to put, yeah, right.
It is a weird one. It is a weird one. It's like, well, no, I'd much rather have $160 in the future, but that means you don't get any money for 10 years.
Yeah.
Does that make sense?
Patience is the best investment.
Well, but again, it's like, where does that number come from? Where does that 10% come from?
Inflation.
Yeah, and it kind of comes from everywhere because.
More people borrowing,
Yeah.
and then the money you actually have is worth more.
Yeah.
Dependent on whether the
Trippy,
system.
dude.
It is.
Yeah, because it all comes back to, it's weird.
Yeah. So anyway, that's the time value of money. So each one of those numbers is actually the same at that 10%. You can play around with it. But so these are the 6 ways to think about either getting the money now, getting it over time, or just getting a lump sum in the future.
So that's like when people get like settlements or whatever, is that kind of like that?
What do you mean?
Like, I don't know, I've never been like in Sweden or anything, but like people owe other people money for settlements, is that kind of like, do they get lump sums, or is it just depend on if the person makes the payments?
Oh, well,
How does that work?
Maybe. I think another way to think of it might be when you win the lottery.
Oh.
You can either, okay, it's a $20 million pot, you don't get the $20 million cash. You might get it eventually, because it's going to pay out over time, or they can say, oh, well, hey, we don't have $20 million, you can just take your,
They give you like
whatever, 40% of it, or some
right,
fraction of it right now.
Because of taxes
Yeah.
or whatever.
No, it's because they don't have it. I mean, they do have a fraction of it right now.
Oh,
Yeah.
so that's why they do the settlements. then.
Yeah, or the
I mean,
same,
not settlements, but I mean, that's why they do like that. You can get lump sum paid up front, or you can do it over time.
yeah, or it's, it's the same way if I wanted to go and take out money from my retirement fund,
Mhm.
I could, but I couldn't have all of it right now.
You get fined.
It's just not there. Yeah, I'd be penalized, yeah.
Mhm. Okay, cool,
Yeah.
that kinda
Yeah.
helps a little bit.
That's how it works, so.
That's great.
Yeah, all right, let's take a little break after that one, that's a good mind bender.
Interesting.
It is.
Economics.
I mean, it's so simple on the one hand, but then when you start really thinking about it, because your emotions get tied up in it.
Yeah.
You know, like, our emotions are, tied up in
It
money.
depends on like how you feel that day, too, you know. like,
Sure, yeah.
Just get it right now, you know,